You are welcome to today's lesson. Today we want to prove the general derivative formula using first principle. The question is, find the derivative of y equals to x raised power n using first principle. Solution. Now, to use first principle to solve this particular question you have on the board, what you need to do first is to add your change in what? The variables. And the variables here, there are two, which are y and x. That means you add your change in y, where we have y, add your change in x, where we have what? X. And this become y plus change in y. This x is per n, you agree with me the same thing as open bracket x all is per n. So and this become where I have x is the inside, so I'm going to add my change in x to it. Now become x plus change in x all raised per n. Now the next thing to do now is to expand this expression here. And for you to expand this, we are going to use our word binomial theorem. Because we don't know the value for this n. I don't think we know the value for n. Maybe n is this per 2. That means you are going to time this in 2 places. With a 3, you are going to time this in 3 places. But now, since you don't know this n, because n represents n of those positive number. So to do that, we are going to use binomial theorem, starting with the coefficient of the first term. And the coefficient of the first term will become the power, which is n combination 0. N combination 0, that will be the coefficient of the first term. Why this first term here that we are having here? The first term in this expression is x. So it's going to start its own power with what? The power of the expression, which is what? X is per n. The second term is what? Plus delta x. That means that will start its own power from what? 0. So the first term starts its own power from the what? The power of the expression. Why the second term starts its own power from what? 0. Then when you simplify this, you are going to get the word, the value of the word, the first term. You move to the second term, which is plus again. That will become, the coefficient will become n combination 1. That will be the coefficient of the second term, n combination 1. Then the power of our first term, which was n here, it will decrease by 1. That is n minus 1. That is how the power of the first term begin to decrease in power, while the second term will what? Increase in power. So the second term will become delta x all raised per what? 1. So we check it from our normal quadratic equation. We have a quadratic equation, the form we got ax plus bs squared plus bs plus c quadratic expression. The power of x here is 2. The power of x here is 1. Decreased by 1. So any expansion you are doing to any of the polynomial, the highest power will come first, then it begin to what? To decrease in power. So that's why I'm having n minus 1 here. So then it continue until, because you don't know the number of terms you are going to have, until you get to the last term, which is certain as well. The coefficient become n combination n. That will be the coefficient of the last term, n combination n. Then by then, the power of the first term, which is x, will become s raised by 0. Then the last term, that means the second term, will become delta x all raised by n. By then, if you observe, this second term is always carrying the base, which is 0. You see here 1. So by then it will be what? Raised by what? N. So if you simplify this, n combination 0 will give us what? 1. From our knowledge of combination, where we have n combination r equals to n factorial over n minus r factorial r factorial. So, and this is n combination 0. It simply means n combination combination 0 will become n factorial over this here minus the 2 from here. That will become n minus 0 all factorial, then 0 factorial. N factorial, see the main n factorial, n minus 0, I'll give n minus 0 factorial, give us n minus n factorial. Then 0 factorial is 1. And this cancel this. So you are left to go. The coefficient to become what? 1. Then 1 times x is power n will give us what? X is power n. Then times x is power 0. Any number is power 0 is 1. So then times x is power 0 is 1. So the first time here is going to give us what? X raised to power n. Everything there will give us x power n. I move to the second term where we have n combination 1. So n combination 1, we see from the formula again, that is n factorial over n minus r. And these two will minus themselves. That is n minus 1 all factorial, then 1 factorial. And that's your n factorial. You see that here, n minus 1 cannot minus themselves. But for us to terminate this factorial, this n factorial can be reduced to n minus 1 all factorial. And that will give us n open bracket n minus 1 all factorial. If the something here is 2, then I continue it until you get to 2. So this one is saying that you still continue, but because I want something to cancel, and that is the denominator, which n minus 1 factorial, so I stop here. Then all over n minus 1 all factorial. 1 factorial is 1. So this cancel this. So the coefficient of the second term become what? N. Then s raised power n minus 1. We don't know the value, so it still remain s raised power n minus 1. So then delta s raised power 1 will give us delta s. So if we multiply, this one give us n times this give us nx raised power what? N minus 1. Then delta s raised power 1 is what? That will give us nx raised power n minus 1 delta x. That will give us our second term. Then we continue, because we don't know their number, to save our time. Let's just take the last one. N combination n will also give us 1. Let's try to solve that. Now give us n factorial over, then we minus these 2, that is n minus n. We then have n factorial over n minus n factorial. That gives us 0 factorial. Then times n factorial. N factorial cancel n factorial. And 0 factorial is 1. So the coefficient of our term here is going to give us what? 1. And x raised power 0 is what? 1. So 1 times 1. Then 1 multiplied by this delta x all raised power n. You give us delta x all raised power n. And this is the expansion of this. All these dots show that you see some other numbers there, but to save our time, because we continue. But this will be the last time. That shows that it has an end. So now that is the expansion of that. The next thing now is to what? To subtract the function from both sides, which is the function now is y. So you are subtracting y from both sides. That will give us y plus delta y minus y equals to x power n plus n x power n minus 1 delta x dot plus delta x all is power n minus y. The y cancel y here, so you are left with delta y equals to x power n plus nx is to power n minus 1 delta x, then plus dot plus this delta s all is power n. Now, what is the value for y? We are going to replace value for y. The value for y from the question is s power n. So I put s power n. So now s power n can cancel s power n. So we are left with delta x equals to nx power n minus 1 delta x plus dot plus delta x all is power n. So the next thing to do now is to divide both sides by what? Delta x. So we divide this one by delta x, delta x, delta x. Delta x cancel delta x. That gives us delta y over delta x equals to nx bracket n minus 1 plus dot plus this using our knowledge of indices. If I have a raised power 2 divided by a raised power 1. So since the base are the same thing, I pick 1, then the power I will minus them 2 minus 1. So here too, that's what I'm going to do because I cannot cut them. That become delta x all with power n. The power of this one down is 1, so n minus 1. So the next thing down is to take the word, the limit of both sides. Then take the limit of both sides. Lim delta y over delta x as delta x tends to 0 equals to lim nx bracket n minus 1 as delta x tends to 0. Then plus dot and this last one lim delta x all this power n minus 1 as delta x tends to 0. So if we take the limit of delta y over delta x as delta y tends to 0, that will give us dy over dx. The limit of delta y over delta x, that is dy over dx. Now if we take the limit of nx this power n minus 1 and delta x is 0, we check there is no delta x here. So that means this is constant. And the limit of any constant is that constant back. So I'm going to have nx this power n minus 1 plus dot plus. Now the limit of delta x all this power n minus 1 and delta x tends to 0. I think when I should replace 0 for delta x here. And 0 raised to power any number because this n represents a number. So 0 raised to power any number is always what? 0. So this will give us 0. Then we add everything together. I'm going to have dy over dx equals to nx raised power n minus 1. And this is the general derivative formula, which is dy over dx equals to nx raised power n minus 1. And the interpretation of this formula is if you check the question we have y equals to s raised power n. The n was power then. And what you are seeing from this proof is that the n come before x, that is the power multiply the expression, which is n times x raised power n. What happened to the power again after multiplying? Then the power decreased by what? By 1. So that means if you have to find the derivative of any number, once the expression is in index form, you use the power to multiply the expression, then you minus 1 from the word, from the power. And that is the proof of the general derivative formula, which you'll be using once the question just says find the derivative. Except if you are asked to use first principle, that will be continue using what? First principle. But once you are given what? Once you are just asked find the derivative of the word of the particular function, we use this formula easily without wasting our time. If you enjoyed the video, don't forget to share to your friends. Keep following, keep subscribing for more exciting videos. Bye bye.